Welcome to Industrial PLC Applications. This video is a review on motor control, forward reversing starters. After reviewing this presentation, you should be able to explain and describe forward reversing starter motor control, explain mechanical interlocking, explain electrical hardwired interlocking, and develop PLC programming for forward reversing starter applications with programmed interlocks. The schematic shown is for a forward reversing starter. To reverse the rotation of any three-phase AC motor, you need to change two of the three motor leads. Notice that when reverse is selected, phase 2 and phase 3 are reversed on the load side of the contactor. Manufactured forward reversing starters must have the following approved features. Both relay coil assemblies must be matched in size and in service rating. There must be a manufactured mechanical interlock, and the output conductor flow through the same set of overloads and termination blocks. Mechanical interlocks prevent the two coils from pulling in at the same time, making them mutually exclusive. Electrical interlocks ensures that the signal that's trying to pull in the two armatures is also mutually exclusive. Both have their own coils, the reverse and forward, and each of them are energized independently, depending on the situation of the electrical interlocks and mechanical interlocks. On the very bottom is the common overload block. When the motor draws too much current, the overloads trip long before the fuse is due. The hardwired schematic shown is a reversing motor control circuit. Notice that this control circuit has no electrical interlocking features. If both the forward and reverse push buttons were operated at the same time, the motor protection fuses would be in direct short circuit. This circuit looks like the last circuit, except there is now a hash line between the two starter coils with a bar. This shows this starter has a mechanical interlock protection feature whereby a mechanical interlock prevents anyone from energizing both direction coils at the same time. We can improve the circuit even more by utilizing the auxiliary contacts associated with the starter itself. Added to the mechanical interlock in the control circuit, there are now electrical hardwired interlocks in this schematic. In the first rung, the normally closed contacts of the reverse contactor are in series with the forward contactor, and the normally closed contacts of the forward contactor are in series with the reverse contactor. This is a PLC program of a reversing motor control circuit. Notice the forward command rung has the reverse command's normally closed condition in series with the output coil. On the reverse command rung, the forward command's normally closed condition is in series with the reverse output coil. In this way, the PLC duplicates the function of the mechanical interlocks, such that both directions are mutually exclusive. During startup, both normally closed contacts allow an initial direction to be selected. If forward is selected, then the moment the rung is true, the forward's normally closed contacts open, preventing the reverse command from activating. The starter's overload auxiliary contacts are placed in the program as normally open because the contacts in the overloads are in the closed position until tripped, and when tripped, it opens the commanded circuit. These inputs are hardwired from the overload block to the inputs on the PLC. If the overloads measure current over full load amperage, the contact's open. In this situation, we're using the output coil from our PLC to control the interlock. We call this coil interlocking. These programmed instructions prevent both contactors from being energized at the same time. However, using this control strategy, you must first push the stop push button to change direction. Alternatively, you can use push button interlocking. Using this control strategy, you may change the direction by simply pushing the other direction's start push button. However, this practice can damage equipment as the torque is immediately applied in the opposite direction of travel.